In the last two videos, we loaded in our data. We now have it in a nice form in an array of case classes. Now I'd like to use the higher order methods to actually start doing the analysis on the data. In order to do that, we have to have some questions we're going to answer. We'll start off with some fairly simple questions. So I'm going to get rid of these prints that verified that we had our data loaded in. And the first question I'll ask is, what is the date of the highest temperature in Detroit Lakes? Which I'm also going to find out. I want to get this whole record here, so I want to find out both what the temperature was, and this should be the T max, and when did it occur. So how could we do this? I'm going to do it first in what would kind of be an inefficient way, but it uses kind of more general methods. So what I'm going to do is I am going to just find the maximum temperature. And to do that, I'm going to take our data and I am going to map it to pull out only the T max. Okay? And then I can just use the max method. That will give me the highest temperature that occurred. Now, the second thing that I can do is to either filter or find a day that matches that. I'm going to go ahead and do filter. It's possible there are some ties in this, and one of the advantages of this approach is that we can find those ties and see how many there are. So I'll call this hot days. That will be our data filtered so that I only take things where their Tmax is equal to max temp. Okay, and now let's print line out hot days. And just so that we can insert, let's do some string interpolation here. Hot days are $hot days. Okay. Run this. It's an array. It doesn't print nicely. That's kind of unfortunate. So what do we have to do here? Well, we need to make it so that it is happier. How about we put some curly braces and use an MK string? Had I used a collection like instead of saying to array, had I used a list or a vector, I wouldn't be having this problem. They print nicely. Okay, so it turns out there are 2 days that are of equally hot temperatures. Let's go ahead and put a comma in there for the future. Otherwise, it's just going to bug me looking at it every time. One occurred in 1936. Actually, they both occurred in 1936 in July of 1936. And it was a high temperature of 107, which for Detroit Lakes, Minnesota, that sounds like that's pretty darn hot. Okay, so that was one way of getting the hottest day, or days in this case. There's a kind of a more efficient way of doing this, though, because the problem with this was that I actually passed through the data 3 times in order to do this. I did the map, I did a max, and then I did a filter. And not only did I pass through the data 3 times, it turns out that map built an entirely new array with 40,000 elements in it that were all doubles. And the only thing I was using that data for was finding the max. So this could be viewed as an inefficient way of doing this with standard Scala collections. Now, what is efficient in standard Scala collections and what is efficient in Spark will actually differ. But I want to get you in the mind frame of starting to think about this, because if you do have very large data sets, thinking about the efficiency of working with them can be significant. What if I only want to find one hottest day? Okay. How else could I do that? Well, it turns out one way of doing this, and this uses a method that's nicely built into the Scala collections. There is a max by method. And what this does is it finds the largest element based upon some function that's applied to them. So I want to find the maximum based upon that. So print line hot s. Hot day 1 is, and the fact that I'm saying 1 probably gives you some idea of what's going on there, hot day. We run this and we get the first of the 2 days that we had before. It's good. It's good that we find one of those days, otherwise one of these things would be broken. Now, you might not always have things like max by available to you. Another way to do this efficiently, so max by can just do a single pass through here. Another way to do this would be with a fold. And getting familiar with folds and feeling comfortable with them is important. So let's start by making hot day 2. We're going to calculate the same thing, but using a fold instead. So data dot, I want to do a, actually in this case, we could do a reduce. I'll do a reduce here. We'll do another example later that needs a fold. So I'm going to do a reduce left, and what this does is it runs through the collection from starting with the first 2 elements, and it applies this function that I'm going to give it to the first 2 elements. And whatever that returns is then applied through the same function to the 3rd element, and the 4th, and the 5th. Reduce only works with one data type, and that is the type that's in the collection. Now in this case I want a temp data, so I'm fine with only working with the type that's in the collection. So we'll call my 2 days D1 and D2, and what I want to do is give us back whichever one of those was warmer. So I'm going to say if D1 dot Tmax is greater than or equal to D2 dot Tmax, then I give back D1, else I give back D2. Now, I run it, it doesn't crash. Let's print this. Hot day, we need to add a 2 there, and a 2 there, and we should get the same result. Both max by and this reduce left are both going to do a single pass through the data. They don't have to allocate any new collections at any point in time. So these are fairly efficient ways of approaching it. They're definitely much more efficient than this, though of course this one did have the advantage that filter gave us back a collection, so it would tell us that there are 2 days. So that's a nice intro. We're going to come back and continue looking at this data and seeing what we can do and what are some of the other higher order methods that can help us do processing on this.